Pleasant day, STEM learners. This is Sir Peter, your basic calculus teacher. So for this topic, we'll proceed to lesson 3.3, which talks about the integrals involving logarithmic functions. So this is just an inserted topic prior to discussing separable differential equations. So let's proceed to our topic, logarithmic functions. So let's review with respect to your Gen Math subject. So a logarithm is an exponent which must have to produce an x. It's actually the inverse function of the exponential function. Do you still remember how to transform or convert an exponential function into its equivalent logarithmic function? So for sure, you still remember this one on your Gen Math lessons. So to transform under the exponential form, the exponent is equivalent to the answer. It's the answer itself. And the base is the base in under the logarithm as well. While the number, which is the answer, is beside your logarithm. So we read this one as the logarithm to the base b of x is y, or some in other books you can read it as the logarithm of x to the base b. So let's have these examples. The logarithm of 32 to the base 2 is equal to 5. So when you transform it into its exponential form, it is 2 raised to 5 is equal to 32. So as I mentioned, the answer is the exponent, and 32 is the power, and then the base is 2. That's why you have to write like that. But if you're given an exponential form, 3 raised to 4 is equal to 81. Correct. The answer is the logarithm of 81 to the base 3 is 4. Now, if you have the logarithm of 0.01 to the base 10 is equal to negative 2, then you can write it as 10 raised to negative 2 is equal to 0.01. Can you follow? This example is actually what we call a common logarithm or a common log. If the base of the logarithm is 10, we can actually rewrite it as the log . There's no need to write 10. Okay, so we can erase that part. Now, what if you have a base e, such as this one? The logarithm should be written as what form? Correct. So the answer is the logarithm of 9 to the base e is y. Notice that this is another type of a logarithm. So this is what you call a natural logarithm. So what is a natural logarithm? Are you familiar with that? So a natural log has a base e. So instead of writing it as the logarithm of 9 to the base e is equal to 9, there's another way, correct way of writing it. So you can write it as an ln of 9. So they are just the same. So you can write ln of 9 is equal to y. So automatically, if the base is e and you are pertaining to its logarithm, you can write it as an ln or a natural logarithm. Now let's proceed to the logarithm of x to the base 5 is equal to 4. Correct. This is very easy. The answer is 5 raised to 4 is equal to x. What about the next one? A raised to 7 is equal to capital M. Correct. It's the logarithm of m to the base a is 7. What about the logarithm of g to the base t is O? you're right. The answer is d raised to 0, or d raised to o, I mean, is equal to g. So this is just a review of your Gen Math. This is our topic for today. Remember that when you get the integral of dx over x, the answer is a natural logarithm of the absolute value of x plus c. So this is just very easy. But some of our problems will involve uh, the variable of integration u. So for instance, you have a du over x minus 3. So that's how you answer if the variable of integration is u. Okay? So, and again, the integral of du over u is equal to ln of the absolute value of u plus c. Let's have examples. Let's evaluate the following indefinite integrals. Let's have number 1. Look at that one. The integral of dx over x minus 3. So, it's like similar with substitution. But this time, we will let u as the denominator as our u value, which is x minus 3, or the u function. Then we find the derivative of the u function. That's 1 dx or dx. So there's no 1 dx actually. You simply write it as du is equal to dx. Then we can substitute now. The integral of du over u, the answer will be an ln of u plus c. So then we substitute u. The u value is x minus 3, so we'll have the ln of x minus 3 plus c. Can you follow? Let's proceed now to the second item. We have the integral of dx over x plus 4. So our u is again the denominator, so that's x plus 4. Then we get the derivative of the u function. So du is again a dx. Therefore, we can rewrite it as the integral of du over u. Okay, remember this is substitution. That is du. This is du. Okay, and this is your u function. That's why we are rewriting it as this one. I hope you understand. Next, we answer this one. So that's an ln, the absolute value of u plus c. But when we replace the value of u, that becomes ln of the absolute value of x plus 4 plus c. So don't forget that we write these absolute values here. Let's have example number 3. The integral of 5 dx over 9x minus 2. Again, the denominator should be your u function. So we have 9x minus 2. And then look at this one. We have a du is equal to 9x. 9 dx, I mean. But since in the numerator we have a 5 dx, so we need to think of an integrating factor. So the integrating factor that we need is a 5 over 9. So we multiply both sides with 5 over 9. So that when we rewrite it, it becomes 5 over 9 du is equal to 5 dx, because this 5 dx is what we need in the numerator. So we can now use substitution. We have 5 over 9, that's the integrating factor, the integral of du over u. Next, we answer the integral of du over u. That's an ln, right? So it's an ln of the absolute value of u. Then we replace the value of u. So this is just substitution. We go back to its x function. So we have 5 over 9 ln of the absolute value of 9x minus 2 plus c. Let's have item number 4. The integral of 9x squared plus 18x minus 21 dx over x cubed plus 3x squared minus 7x minus 5. So again, the denominator should be u is x cubed plus 3x squared minus 7x minus 5. And the derivative of u is this, which is 3x squared plus 6x minus 7 dx. But observe how is it related to the numerator. We simply multiply it by 3. So it means our integrating factor is indeed 3. So that it becomes 3 du, and then we'll have 9x squared plus 18x minus 21 dx. So we can replace this one now as our 3 du. So that becomes a 3 integral of du over u. Next, we answer the integral of du over u. That's an ln of the absolute value of u. And then we replace again by the u function. We have 3 ln of x cubed plus 3x squared minus 7x minus 5 plus c. So that is how easy it is. I hope you can follow. Can you try the following examples? Yes, you can try on your own. Okay, let's answer. Let's have the first item. Let's have item number 5. This time, our variable of integration is with respect to y. So what if we have the integral of 2 dy over 9y minus 4? So again, our u function is a 9y minus 4. Then our du is 9 dy. But we have to think of an integrating factor that when we multiply it, it becomes a 2 dy. So the answer is 2 over 9 du is equal to 2 dy. So we can now use it by substitution. We replace 2 dy as 2 over 9 du, then over u. So it becomes like that, 2 over 9, the integral of du over u. Then the answer becomes an ln, right? A natural logarithm. So we have 2 over 9 ln of the absolute value of u. Then we'll get 2 over 9 ln of the absolute value of 9y minus 4 plus c. I hope you understand. Let's proceed to item number 6. But if you have the integral of 3x squared dx over x cubed plus 7, so this will just be easy. So u is x cubed plus 7. Our derivative of u is 3x squared. Oh, that's a typographical error. So that's a 3x squared dx. So we'll have the integral of du over u. And of course, the answer is an ln of u plus c. So the final answer becomes an ln of the absolute value of x cubed plus 7 plus c. So take note, do not forget to write your dx. Let's have the next one. The integral of 40x cubed minus 100x dx over x to the fourth minus 5x squared. So we have a u function, which is x to the fourth minus 5x squared. The derivative is 4x cubed minus 10x dx. But since it is somehow, 4 is somehow related with 40 and 10 is related to 100, so we need to multiply an integrating factor, which is 10. So that it becomes a 10 du, 40x cubed, minus 100x dx, which is our numerator. So we can apply now the substitution. So we have 10 integral of du over u. And we'll have 10 ln of the absolute value of u. Substituting the u value, that is a 10 ln of the absolute value of x to the fourth as 5x squared plus c. So I hope you understand. Now, notice that all of the problems that I have presented with you have a denominator which is usually 1 unit higher than the numerator. But what if the given examples are like this? Observe. This is a higher degree compared to the denominator. Again, this is 2 degrees higher. So usually it should be the denominator which is higher. So in this example, you simply apply division first. Let's take a look at number 8. The integral of x cubed minus 9x dx over x squared. So first you have to divide. You have the integral of x dx minus 9 over x dx. And then you'll have, so you use the regular power rule. So that's addition of plus 1. So you'll have x squared over 2. Then for this one, you'll have a du over u. It's like a du over u, right? So the answer here will be a natural logarithm. So to get the final answer, you'll have x squared over 2 minus 9 ln of x plus c. Do not forget the absolute value. Okay? Let's have the last item. Integral of x to the fourth plus x minus 4 over x squared plus 2 dx. So, we can divide actually x to the fourth. And then since we have a missing 0 x cubed, then we have a 0 x squared minus 4. So we are actually dividing it by x squared plus 0x plus 2. So we divide the first term first. X to the fourth divided by x squared is x squared. Next, we multiply x squared times x squared. That is an x to the fourth. So you apply long division, okay? X squared times 0x is 0x cubed. X squared times 2 is 2x squared. So we subtract, cancel. So this becomes negative 2x squared. Oh, we forgot the 0x here. Then we bring down 0x minus 4. Next, we divide. We have negative 2x squared divided by x squared. So that's a minus 2. And we multiply. Negative 2 times x squared is a negative 2x squared. Negative 2 times 0x is a 0x. Then negative 2 times 2 is negative 4. So you see, when we subtract, this it will be cancelled. And the answer is, let's go back. So we have, allow me to rewrite it again. An x to the fourth plus 0x cubed plus 0x squared plus x 0x minus 4. So minus 4. Then we rewrite it as x squared plus 0x plus 2. Again, let's do the division process. X to the fourth divided by x squared is an x squared. Then x squared times x squared is x to the fourth. X squared times 0x is 0x cubed. X squared times 2 is a 2x squared. And then we subtract, so cancel. So we'll have negative 2x squared plus 0x minus 4. We divide again. Negative 2x squared divided by x squared is a negative 2. Then we multiply. And then we have negative 2 times 0x is 0x. Negative 2 times 2 is, and the entire will be cancelled. And so the entire fraction will be the integral of x squared minus 2 plus x over x squared plus 2 dx. Next, we get the integral. We'll have the integral of x squared dx minus 2, the integral of dx plus the integral of x over x squared plus 2 dx. Next, we let u as your x squared plus 2 and your du as 2x dx. And we get the integrating factor, that is 1 half du is equal to 2x dx. And then the final answer is x cubed over 3 minus 2x plus 1 half ln of the absolute value of x squared plus 2 plus c. So this is again Sir Peter. I hope you learned something from this with your lesson. Good day and God bless.